All right, so it's time for us to kick off this webinar. It's 1:30. So welcome all of you who decided to join us today. Really happy to have you here. If you haven't heard of Novotek Explore, this is our second webinar where we do Novotek Explore. And it basically came up as an idea where customers were coming to us in our different countries, asking or telling us that they like the webinars that we host, and we really like to host webinars as well. So we thought, why not join forces? And that's how Novotek Explore was born. So basically, we tried to make it a really short format where we talk about a topic that has some sort of traction in industrial technology. But we're super happy to also have Mitan joining us from GE Vernova. And he's a business consultant in GE Vernova, very good at talking about AI. So I will actually leave it over to you, Mitan, to kind of present yourself, I think.
So hi everyone, Mitan Solanki, I'm a business consultant based in the UK. I've been with GE for 13 years in total. Started as a developer in the oil and gas business as it was back then, moved into GE Digital, where I was responsible for a lot of sales on some of our predictive analytics software that we were selling at the time. Be it cloud or on-premise. And more recently, I tend to focus a lot more on sort of process optimization and analytics within the manufacturing space. So that's a little bit of a background. And today's session really that I want to take you through is really a mixture of things. One is sort of just positioning and framing a little bit about AI, so just from a layman's perspective, and then sort of taking you through a little bit about industry opinions, and then perhaps giving some examples of where these worlds of AI and manufacturing potentially can come together. So that's going to be the thrust of most of what I talk about. Okay, so let's get on with the slides. So what is AI? So really at a high level, it's a field of computer science that focuses on developing algorithms and systems that are capable of simulating human-like intelligence. So AI at its core is really just a collection of techniques such as machine learning, where computers learn patterns from data, things like natural language processing as well, which enables machines to sort of understand and, in sort of the Gen AI world, generate human language. And basically, a lot of these techniques are sort of under the umbrella term of AI. So they're either mathematical models or statistical models that are trained with large data sets to recognize patterns and make predictions, for example, when new information comes in. So in general, AI is really just about trying to mimic really what a human does, but trying to quantify that in terms of models. So just to frame AI and some of its sort of constituents, I would say, a lot of organizations, right, at this stage have been doing what we call quote unquote AI for many years, 15 or 20 years. And they've been doing that in the form of things like machine learning. So machine learning is probably the biggest subset of this collection of techniques, I would say, that we call AI. And really, it's a program or system that trains a model from input data. And that trained model can then make useful predictions from new data coming in or never seen before data. So while in traditional sort of programming, developers would write an explicit instruction for a computer to execute, in the world of machine learning, essentially, you're taking algorithms and it's learning patterns and relationships in the data to make predictions, right? So they can be done in an unsupervised way, which is, hey, it's just a black box, or it can be supervised where you tag it with certain outputs that you want to see. And then, within that machine learning branch, you've got things like neural networks, and neural networks, again, are a subset of machine learning, but the main thrust of it is inspired by the human brain. So mimicking the way that our neurons in our brain are connected to one another, and how we actually eventually as humans make decisions. So basically, in this world of sort of neural networks, you've got different layers of neurons, let's say, which are just essentially points in space with a different weighting, and they're organized in just a few layers, right? And Google, for example, you've probably seen Google Images, where you upload a picture and it kind of identifies what it is. That's using neural networks, and that's been doing that for at least 10 years, maybe if not more. So you put up a picture of a teapot, and it's smart enough through neural network to know, oh, this is an image of a teapot. Yeah, that's the classic example of where that's a neural network is used. You then go into things like deep learning, right? So that's where you've got a neural network, but with many layers, or hidden layers. So the moment you go more than 3 layers, you're sort of in the world of deep learning. And deep learning is more suited for tackling, complex real-world problems. So things like image recognition, which is a deeper form of what I just explained before, and going more than object detection in things like your smartphone camera. Things like facial recognition and autofocus and autonomous driving have deep learning powering them behind them. So it's different to just saying, okay, I've seen an image, which is what you do in neural network world, and it'll probably identify a shape of a face, knows it's a face, maybe obviously the complexion of the color of the face. Deep learning is really fine-tuned at identifying specifically whose face that is by looking at various wrinkles as we get older, or various traits. And that's exactly how the human mind works. The human mind is using deep learning all the time, and so that's the complexity that I'm talking about when we're talking about AI. As a general term, that's what it covers, but there's different layers into neural networking, into deep learning, which are prevalent in day-to-day use. And Tesla have obviously been experimenting with this for at least 8 years or more. So AI has been around for a long time. I guess that's the core message. And the bit we see more today is, again, another subset then of deep learning. And we call that generative AI. And then within generative AI, you've got foundational models and large language models, which I'll talk about in a moment. But the idea here is that you're generating new types of content, right? And that's the key thing when we're talking about large language models. So generative AI is the form that generates new content rather than just finding and classifying existing content. So there's different types, right? So you can see here there's things like text to text. So you put text as an input and it will generate text as an output. You can put in text as an input and it can generate you an image as an output. So again, it's about creating something new, and that's basically where the whole world is sort of taken off on this type of AI, is that you're providing sort of natural language prompts. So you're not having to be a data scientist or someone who's studied computer science or machine learning for 10 years. You can just use as a human natural text input, and the model will basically be instructed to do what it does. So, you can see as time evolves, we would get to a stage where, you want to generate video, which you can do at the moment. But imagine sort of sitting at home, you finished a Netflix series, yeah, and you're now in the world of generative AI. You weren't happy with the ending of that, Darth Vader didn't need to die, you want him to live on to do another series. Okay, you can put that into Netflix, the all artificial intelligence Gen AI encompassing Netflix, and you can spin off a completely new series that's in tune with roughly an avenue that you want to take it down. So again, you're using just natural text input to generate a series of videos. So that's really crucial here. So again, the thing that started this revolution is the whole idea of natural language processing, not being a data scientist, and being able to generate new content from things that are trained. And obviously these large language models, they're trained on vast amounts of data. In the real world, when you're talking about applying it within manufacturing, it's going to be just an end customer's subset of data that they want to interrogate. So I sort of bring it a little bit back to what we have here in the world of neural networks, right? So typically how it works is that, when you're talking about a large language model, it's basically an artificial neural network, right? So at the core of everything you see, you're still in the world of neural networks and deep learning. So, I can write something like, whales are ... I send this to a large language model, it eventually gets converted to a set of numbers and it's processed with a certain weighting, just as you would in the neural network world. And then the resulting numbers are converted back into text, right? So in this case, it says, right, mammals is the most relevant word here. right? And the interesting part is if you take that output, the word mammals, and then combine it with another input, send it through the model again, then it will continue to add new words. And that's exactly what's going on behind the scenes when something like ChatGPT generates a whole story. So it's basically taking new outputs, feeding them back into the model, and looking at a weighting and going back and back and back. And that's how you can end up with an entire paragraph or an entire book that's just written with ChatGPT. So that's just a grounding, right? A bit of a grounding on where we are in the world today. You know, you got these two big sub blocks. You've got neural networks, right, which have been around for a while and have been applied to many, many different things. And you've got sort of the buzz around today, which is all around LLMs and foundational models. And you know, what I'll go into now is each have their own merits where they can and can't be used, I would say. So in industry, what we see typically is on the right hand side. This is a study done in 2023 by sort of executives at some very, very large enterprise companies, so at the C level. And at the time they started to invest in things like Gen AI, right, to try and apply it to various things. And then you've got about a third that are doing some initial exploration, some that are not doing anything yet, although I strongly suspect that the very light sky blue there is diminishing rapidly, where you've got a lot of people, large organizations, starting to experiment with it. And even in this initial stage, the types of applications that they were looking at were things like customer experience and customer retention. So these probably were things like chatbots, right, that were there, that just popped up on a website where they could interact and seemingly be talking to the organization when they're not. Revenue growth, so maybe forecasting financials, for example, cost optimization. And I think here the key message, I think, is that for a lot of points where you want to start and venture into this world, it's really not just a case of we need to start jumping on AI, right? A lot of the time there needs to be a use case, and that's what we found, a use case that's value driving for the business and actually feasible to execute on, regardless of whether it's using AI or not. Because there are some use cases that are not a good fit for Gen AI and they don't merit any further consideration. So you want to map the use case really, and then see whether something like AI, Gen AI, fits. So, where it's highly useful would be for things like content generation, as I spoke about earlier, or conversational user interfaces, or, new knowledge discovery more within a text sort of format. Where Gen AI is not useful is for things like prediction or forecasting or planning or decision intelligence or autonomous systems, right? For that, you probably go further up the scale, right? So up here, prediction and forecasting, decision intelligence, that's where your traditional neural networking and machine learning come into play, especially if you're dealing with a lot of numeric data. You want to throw a whole bunch of quantitative data at something to try and predict or forecast what might happen in the next 24 hours. Whereas Gen AI is really not designed for that at all, right? Gen AI is more at the generation of image and video, and maybe starting to identify initial little patterns in data, but they're not there yet. And likewise, if you look at what some of the people say here, is that you're looking at executives who kind of initially started to say, right, I need to look at value, I need to look at feasibility. Where does that sort of intersect? And of course, the first thing here is data insights. We want to know more about our data. Again, Gen AI, is it necessarily the best tool for it? Well, it depends on the type of data. If it's very quantitative, probably not. If the type of data that you've got is a lot more, I'd say even tabular is not there yet, but even data that's presented in a more text way. So you've got documentation. That's a good place to start. So if you look at some examples, let's say, of sort of domain utilization of AI in general within the manufacturing space. So typical sort of machine learning and neural networking is really good at projecting things like customer trends or times or seasonality. When the holiday season is coming up, for example, it can quite accurately leverage many years of historic data to understand what's coming up, or whether you're going to have a shortfall in your supply, right? So your suppliers may have bummed out historically in the past. How can you take that into account with what you're going to produce? And that again helps with things like production planning. So using AI to figure out when to source raw materials based on, it could be the weather, again, it could be seasonality in terms of sales, and then maybe help schedule optimal production with optimal people. Then you've got use cases, things like natural interaction with your ERP systems. Again, that's a good fit for something like Gen AI. And I'll show you an example of where we do this a little bit later on with a manufacturing execution system. Then you've got things like root cause analysis for quality, adjusting production orders in real time. Again, that probably sits a little bit more in the realm of traditional machine learning. Querying of manufacturing related documentation. Okay, that's very much Gen AI. That's its sweet spot, where you throw at every piece of documentation you've got, you could start to ask questions of that documentation in a real manner. Same with standard operating procedures as well. And then you go into things at the bottom like identifying hazardous working conditions. Now, that's something that both, I think, excel at in a way. Deep learning is probably better. So what it could do is you can use something like deep learning to identify, image by image, that there are certain hazards there on the plant floor through a video feed. And each slice of that video, each frame by frame, can be analyzed. And then at the end of it, you can then use an LLM. So again, moving on from just the deep learning side of identifying hazards from an image, you can then use the LLM to then send a message or an email to say, this is what we believe is happening. This is something that you want to act on as an email, for example. So there's lots of different examples of where things like this can be used. So, where's a place you can start? We have within the GE portfolio a solution that's been leveraging and making use of things like neural networks for many, many years, 15 or 20 years, right? And within here, you've got the capabilities to do some of those things I mentioned before. So things like root cause analysis, monitoring, monitoring and providing some early warnings, prediction and forecasting. So essentially building models within a solution to try and say, hey, look, if I build a model to represent what's going on my line, for example, or on certain machines along the line, how can I start to think about improving quality or improving throughput? So you then move into things like simulation, which is to say, okay, I've sort of built a model. It could be a neural network based model, for example, where I have a really, really good idea of what the inputs are into my process. I have an idea at the end of the quality of the product that I produce at the end. Can I build a model that represents all the relationships of all my input parameters going in? So it could be supplier, it could be the temperatures, it could be the pressures from a quantitative perspective that go in. And at the end, you do a final test on quality. And, a lot of the time you find that within the manufacturing world, process engineers are scratching their head to say, well, we thought we put exactly the same thing in terms of our inputs, but we're getting different outputs. What's going on here? And that's, a classical sort of problem that you would start to apply things like neural networks to, building relationships between that data, and then hopefully finding some correlations that you can proactively work on. So, it could be a stage where you maybe want to produce more. So you could say, well, what if I ran in the process world, if I ran my line speed an extra 2 meters per minute, what would the final effect be? So you're producing more, but does that have a final impact on the quality of the products at the end, or the mechanical properties of that product at the end, which again may make the quality better or worse, or will it introduce more scrap? Right. So at that point, you can then build a model to say, well, what if I were to tune this input parameter, or raise the temperature, or increase the pressure, for example, or like I say, increase the line speed? What effect would that finally have? And I'd say in this world, you don't need to be in the world of Gen AI to do something like that. The techniques and tools for that have been around under the umbrella of AI for decades already. So I would say key thing is really look into the use cases, and then see in that diagram of circles where the capabilities fit. Now, if someone wants to bring those worlds of Gen AI together, then within the solution that we call CSense, you have the ability to generate. You have the ability to execute on models. So you can go to something like ChatGPT and say, "Hey, generate me a Python script," because it's very good at generating text and code. Generate me a Python script where I can do some machine learning to predict a numerical output. Yeah. You can take the code that it generates, you can drop it into a Python block here within the CSense solution. Then you can hook it up on the left-hand side with a database. So it could be a historian, It could be a SQL data set. It could be text or Excel files, and then you can start running it through that model that you just generated in ChatGPT. And the key thing is you can actually execute on it. So as an output, you can then directly have the output of that model either return the data to a historian, so you can just visualize that data, or you could have that data, for example, make its way all the way through to an OPC server where it can actually directly interact with a DCS system and PLCs and make, open a valve here, for example, or relieve some pressure here or increase the temperature. You can actually have a full closed loop of what it is that you're trying to do. So really, in this regard, something like CSense here would be a really, really good industrial execution engine of the analytic that you went to ChatGPT 4 to generate. So you're sort of combining the two worlds of sort of industrial automation with the world of generative AI, should you need to. And this is a really good solution where it enables you to do something like that. A lot of the time you find in this sort of day and age that there's a lot of analytics and data science that's done on the cloud, but when it actually comes to executing it on the plant floor, where you've got process engineers and you've got demands on the plant floor for it to actually make a difference, sometimes those two worlds are too far apart. So I'll go into an area here where we've got an MES system in the background, and essentially what you're doing here is you're querying your MES database and your historian, again using just natural language prompts. So you're saying here, show me my active alarms, and it will go away and pull up the latest sort of 5 alarms that it sees when it started, and again on what units it was and what the description was. You can then say, show me my alarms on a particular test unit yesterday. Again, you're giving it a defined time. So it will come back. Again, you're using generative AI here. You're using an LLM here to go and basically convert that query into something that will go and retrieve what you need from your database. Show me a chart of alarms. So you're specifying how you want that visualized in this particular scenario here. So you can say here, what was the OEE from a defined time window, right? And again, it's broken it down by shift here. And then you forgot what the abbreviation WP1 means, right? It's a white paint gallon. So you're querying your data as you would be just as a human, right? You're querying it in the most natural way possible. So the LLM here is really, really powerful in understanding exactly what data you want based on just a text input. You're not having to write hundreds and thousands of different SQL queries to get the data that you want, for example, here. The power of Gen AI and the power of the LLM here is making that translation. So what it's not doing is directly interacting with the SQL database or the historian here, right, or the MES database. What it's doing is the LLM has trained itself on the APIs. In this case, there's REST APIs that are calling into these databases. So it knows the REST APIs and it's trained on all the different REST API function calls that are available for these databases. And essentially what's happening is when you enter a text input, it will identify the right combination of REST API calls to make based on what you put in. So you're saying, I want to query here, for example, a specific tag, and I want it in a specific format, and I want it for a specific time. It will take those 3 variables into account and generate the right REST API calls to then take that data back, and where you can obviously visualize something. So here you're saying, show me the top 5 reasons for waste this month based on a waste amount. Yeah, so 5 reasons, waste, and the month. Right, so it's going to take those 3 items and go and retrieve that information for you. So here you can see different waste amounts based on materials, based on personnel, based on resources as well. And here, again, it gives you a list. So you're asking basically the large language model, what can you do? What can you fetch me? Just in case you're curious, you can look at crews, shifts, production events, paths, orders, starts, alarms, different variables, and then even within the historian, different tag values. Okay, so I think we're almost at time. We've got a little bit of time here for some Q&A. So yeah, if there's anything that you want to ask, feel free.
All right, thank you so much, Mitan. Really, really interesting. And I think especially the last demo is really cool. You can actually see those worlds meeting. But we have some questions already. So, but what we already got was firstly, what role do edge devices play in AI? When is cloud versus edge preferred?
So I think that there's now a growing capability of bringing things like LLMs down to sort of an on-premise level. So for edge, when we're talking about edge devices, usually edge devices are designed for things like bringing in the data and transporting them somewhere. So whether it's for storage locally into a historian, whether it's an edge device which is sending data to somewhere in the cloud. I think there's two separate things here. I think edge devices really are used for transporting data somewhere. Once it's either in the cloud or on premise, then the second part of the question, I guess, becomes what do you want to do from an AI perspective with that data? So you can move that into become a database. So that data that you've taken from the edge device, you can put it in the cloud. You can store it in different types of databases. So AWS, Azure, even our historian, there's different ways you can store that data. And then what customers are trying to think about now is where they want that large language model to run, right? So what I just showed you in the demo is interacting with a large language model, which is on the cloud. Some customers will say, well, actually, I'd rather that data, that large language model not be in the cloud for whatever reason, whether it's security or whether they're in a very, very tightly governed industry. If an organization is willing to spend a lot more money, they can bring that LLM down to the edge, or I would just say on premise for now. And if they have enough computational power, there's options to set that up on premise to do some of the Gen AI related interaction that I was just showing there.
Perfect, thank you. And the second one was, how do you get started with what you showed as a demo? What do you need? I think in terms of software, hardware, yeah.
So again, there's a whole host of options. So just in terms of core building blocks here, in what you just saw there, you had our plant applications MES solution there in the background, which again had a lot of information about things like downtime and quality and production events. You also had our historian there. So those were the two main data sources. And then each of those data sources have a way to interact with them, right? So you've got a set of REST APIs, for example, for the historian. You've got some SQL queries, for example, for plant applications or REST APIs. And essentially, the way it worked was me as a user would take a text input that would go to a large language model. So again, you could be using OpenAI's ChatGPT. You could be using Gemini, Google Gemini. You could be using AWS's Bedrock. Essentially, all that LLM is doing is taking your input and then it's spitting out a REST API call or a SQL call based on what it's been trained on. So it's been trained on how those calls work for plant applications and historian. And all it does is then it converts your natural text input into a REST API and a SQL query. It'll go and fetch that data out of there and then display it to you in a way, here we're using Streamlit, but it can display it to you in the way that you specified. So as a table or as a chart or as text.
But I can just say thank you so much, Mitan, for sharing. It was super interesting for me as well, even though I'm not an engineer. And you made it a little bit more tangible, I think, compared to what I thought about AI and manufacturing before this. So thank you so much for taking your time. And if you have any more questions regarding CSense, plant applications, and so on, you can always, of course, reach out to your local Novotek team as well.